The moon. It's our closest celestial neighbor, a symbol of mystery and wonder for centuries. But how much do you know about it? In today's video, we'll journey to the moon, exploring some of its most fascinating secrets. Did you know the moon is slowly drifting away from Earth? It's a fascinating phenomenon that has been happening for billions of years. It's true. Each year, it moves about 1.5 inches farther from us. This might not seem like much, but over long periods, it adds up significantly. This slow but steady retreat is due to the complex dance of gravity between the Earth and the moon. The gravitational forces at play are intricate and fascinating. As the moon orbits our planet, its gravitational pull creates tides, not just in our oceans, but also in the solid Earth itself. These tidal forces are a direct result of the moon's influence. These tides create a slight bulge in the Earth, which has a gravitational effect on the moon, pulling it slightly forward in its orbit. This interaction is a key factor in the moon's gradual escape. This extra bit of energy causes the moon to slowly spiral outward, away from us. It's a process that is almost imperceptible on a human timescale, but monumental over geological periods. Over billions of years, this subtle shift will affect the tides here on Earth and the length of our days. As the moon moves away, the Earth's rotation gradually slows down, leading to longer days. In the distant past, the moon was much closer to Earth, and days were significantly shorter. As the moon continues its great escape, our days will keep getting longer and the tides will change in ways we are only beginning to understand. Speaking of tides, let's dive a little deeper into the moon's influence on our oceans. The moon's gravitational pull is strongest on the side of the Earth that's facing it, creating a bulge, a high tide. On the opposite side, the moon's gravity is weaker, creating another high tide. Since the Earth is rotating, different parts of the planet experience these high tides throughout the day. Without the moon, our planet would still have tides, but they'd be much smaller and weaker. The sun also exerts a gravitational pull on our oceans, but its effect is less pronounced. You might think of the moon as a silent, still world, but it's not as quiet as it seems. Like Earth, the moon experiences quakes, or, as we like to call them, moonquakes. These lunar tremors are caused by gravitational interactions with Earth and temperature changes on the lunar surface. As the moon orbits our planet, the Earth's gravity pulls on the moon's interior, creating stress that can build up and release in the form of moonquakes. Temperature changes also play a role, causing the lunar crust to expand and contract, triggering moonquakes. While most moonquakes are relatively weak, some can be quite powerful, reaching up to 5.5 on the Richter scale. Today, the moon might seem like a cold, geologically dead world, but billions of years ago, it was a hotbed of volcanic activity. The surface we see now is a testament to its fiery past. Imagine a time when the moon's surface was dotted with active volcanoes, spewing lava and reshaping the landscape. If you look at the moon, you'll notice dark, smooth plains scattered across its surface. These plains are not random. They tell a story of intense volcanic activity that once dominated the moon. These are called maria, Latin for seas, because early astronomers mistook them for actual bodies of water. They thought these dark patches were vast oceans, but they were actually vast plains of solidified lava. Billions of years ago, volcanic eruptions spewed out molten rock that spread out over the lunar surface, creating these distinctive dark patches. The lava would flow across the surface, filling in craters and low-lying areas, eventually cooling and solidifying into the maria we see today. The moon's volcanic activity peaked between 3 and 4 billion years ago, and gradually died down over time. This period of intense volcanic activity was crucial in shaping the moon's current appearance. By studying the composition of these lava plains, scientists have been able to piece together a timeline of the moon's volcanic past. These studies have revealed not only the age of the lava flows, but also the conditions under which they formed, providing a window into the moon's fiery history. For a long time, we thought of the moon as a dry, desolate world, completely devoid of water. The surface appeared barren, with no signs of the life-sustaining liquid we take for granted on Earth. This perception shaped our understanding of the moon for decades. But in recent years, one of the most exciting discoveries in lunar science has been the confirmation that there is, in fact, water on the moon. This revelation has transformed our view of our closest celestial neighbor. Scientists have found evidence of water molecules embedded in the lunar soil, and this discovery has opened up new possibilities for exploration and habitation. The water on the moon exists primarily as ice, hidden away in permanently shadowed craters near the lunar poles. These craters, which never see sunlight, provide a cold trap where water ice can accumulate and remain stable over long periods. This ice is a precious resource that could be crucial for future lunar missions. These craters are incredibly cold, some of the coldest places in our solar system. Temperatures in these shadowed regions can plunge to below -250 degrees Fahrenheit, making them perfect for preserving water ice. The extreme cold also presents challenges for exploration and extraction, requiring advanced technology and careful planning. The discovery of water ice on the moon has huge implications for future lunar missions and space exploration. It means that astronauts could potentially have a local source of water for drinking, growing food, and even producing oxygen. This could significantly reduce the cost and complexity of sustained lunar habitation. Instead of having to haul all our water from Earth, we could potentially use the moon's own resources to sustain a lunar base, or even launch missions deeper into space. This could pave the way for a new era of space exploration, where the moon serves as a stepping stone to the rest of the solar system and beyond. From our vantage point here on Earth, the moon appears perfectly round, a celestial pearl hanging in the night sky. But would you believe that the moon is actually slightly egg-shaped? It's true. Billions of years ago, when the moon was much closer to Earth and still partially molten, the Earth's gravity exerted a strong pull on the lunar surface. This pull caused the moon to bulge out slightly on the side facing Earth, creating a slight asymmetry. Over time, the moon cooled and solidified, but this egg shape remained frozen in place. This subtle egg shape affects the moon's rotation and its gravitational interactions with Earth. We always see the same face of the moon staring back at us from the night sky. But have you ever wondered what the other side looks like? The far side of the moon is a very different place from the familiar near side. The near side, with its dark Maria and bright highlands, is the face we know and love. But the far side is heavily cratered and almost entirely devoid of those smooth dark Maria. This stark contrast is due to a phenomenon called tidal locking. Because the far side has been facing away from Earth for billions of years, it's been more exposed to impacts from asteroids and comets. Imagine walking on the moon. What would it feel like beneath your feet? Well, you wouldn't find solid rock. Instead, you'd sink into a layer of fine, powdery dust and rocky debris known as regolith. Regolith covers the entire lunar surface, a testament to billions of years of impacts from meteoroids and micrometeoroids. Every time a space rock slams into the moon, it pulverizes the surface, creating a fine-grained powder. Over time, this process has created a layer of regolith that can be meters deep in some places. Regolith is incredibly abrasive, can wear down spacesuits and equipment, and can clog up machinery. But it also holds valuable clues about the moon's history and composition. Unlike Earth, with its cozy atmosphere that protects us from the harsh realities of space, the moon is a pretty unforgiving place. It has no significant atmosphere to speak of, which means its surface is exposed to the full fury of the sun's radiation and the extreme temperatures of space. During the lunar day, temperatures can soar to a scorching 250 degrees Fahrenheit. But when the sun sets, the temperature plummets, dropping to a frigid -250 degrees Fahrenheit. This extreme temperature swing is due to the lack of an atmosphere to regulate heat. This lack of an atmosphere also means that the moon is bombarded by radiation from the sun. The moon might seem like a distant neighbor, but it plays a surprisingly vital role in shaping life here on Earth. One of the moon's most important roles is stabilizing Earth's tilt. Without the moon's gravitational influence, our planet's tilt would wobble chaotically, leading to extreme climate swings. The moon's gravity acts like a steadying hand, keeping our planet's tilt relatively stable over long periods. This stability is crucial for life on Earth because it allows for relatively predictable seasons and prevents drastic temperature fluctuations. The moon also influences the behavior of many nocturnal animals and has been a source of inspiration for cultures throughout history. The moon is more than just a beautiful sight in the night sky. It's a key part of Earth's story and a stepping stone for our exploration of the universe. From its volcanic past to the discovery of water ice, the moon continues to surprise us with its secrets. Which fact surprised you the most? Let us know in the comments, and don't forget to like, share, and subscribe for more fascinating space facts. Thanks for watching.